we have Hitchhiker's Guide to the EVM by Viraz Malhotra. So let's welcome him.
Hello everyone, so today I'm going to talk about Hitchhiker's Guide to the EVM. For those who are, some of you might be unaware of the reference. There's a fictional book called Hitchhiker's Guide to the Galaxy, which is a guide for interstellar hitchhikers. But I'm not going to go into that, but Hitchhiker's Guide to the EVM, I'm going to talk about it. Give you guys an intro / refresher memory about EVM, aka Ethereum Virtual Machine, and aka the execution layer of Ethereum, and some important concepts around it. And also, in the end, for people who are interested in writing smart contracts, who are writing smart contracts already, just dive into some basic gas optimization tricks that you can use based on your knowledge of the EVM. So let's begin with an intro. So again, I know it's afternoon right now, but with Web3 we like GM better. So my name is Viraz. I'm founding member and lead blockchain engineer at Good Ghosting, which is a DeFi protocol on Polygon and Celo. And I'm also contributing to DAOs. At the core, I would say I'm pretty much a smart contract developer. So let's get started and dive deep into EVM. So what is EVM? Basically, it's a virtual machine running inside each Ethereum node, right? It defines rules for computing a new valid state each block, aka we are dead without it. So and it executes as a stack machine, i.e. Basically what happens is, as a new state, like I mentioned before, when we compute a new valid state, EVM needs instructions to do that, and those instructions are basically, they require inputs, and those inputs are basically placed on a stack, which is the data structure, right? And when EVM executes the results from those instructions, the results are again posted, onto the stack. So that's why I say it executes as a stack machine, right? Now I'll just dive a bit into. And I'll try now to make it fun and informative, right? I'll try my best. So I'll just dive into a bit onto the EVM architecture. Right, and just discuss these components, like not dive deep into them, but just give you a gist of all these components, right? So firstly, we have the EVM code. Basically, for example, if you have written you might have seen, or you've written a smart contract, for example, in Solidity, right? What happens is that when you compile that smart contract, because EVM cannot read Solidity, right? It can only read bytecode. So what happens is that the compiler converts your Solidity code into a bytecode that EVM can read, and that's basically a set of instructions, right? That EVM can read, interpret, and execute accordingly, right? So that's that, and this is an immutable part. This architecture is based on each smart contract's instance, right? And the code is pretty much immutable, like you all know. You cannot change the code once it's deployed, right? So and then basically storage is the persistent part of the memory, where basically it's a JSON map. It's a mapping. You can treat it as a JSON mapping of 32-byte key and a 32-byte value, right? You might have seen in smart contracts how you access the data. That data is actually stored in storage, so you have a key to access it, and then there's a value that you get, and the maximum size of that value can be 32 bytes for each slot. Right, so there are multiple storage slots, right? Then coming on to the volatile part of the machine state, basically first a stack, right? So again, like I mentioned before, each EVM instruction, needs inputs, and those inputs are placed on stack, and the results again are placed back. So stack is a very, very important component, right? Then we have the memory, which is basically which exists this part of storage basically exists only during the time of the smart contract execution, right? So again, if you have written any smart contract, or you might have seen the code, there's a keyword called memory that's used. So that's basically this. And it is not a part of the storage, so it's not persistent. It only executes if, for example, you called a function in a smart contract. So that memory will just exist inside the scope of that function, for example, right? And this is again accessed via an offsite. So this, unlike storage, this does not have any key. In fact, instead it has an offset, so you can access, which is basically the position, where the item is located in memory, right? So you can access it via an offset, right? And then we have, which is pretty logical, that we have EVM also, tracks the gas that's left, because each transaction requires gas to execute, right? And EVM needs to keep a track of how much, and each instruction that EVM executes costs gas, right? So it has to keep a track of how much gas is left, right? And then we have the program counter, which is again a pretty important part of it, because, for example, as instructions keep coming in, EVM keeps executing them. Once it executes, it needs to know where the next instruction is, right? And program counter is basically keeps that track. So it tells the EVM that this is the next instruction, points EVM to the next instruction, basically, right? So that's basically the gist sort of the architecture of Ethereum, of EVM. Basically, I hope it wasn't, it was a technical thing, but yeah, I hope it's not that boring, or you guys are still, listening to me. Then will come, now this is the interesting bit, right? So the reference that I mentioned at the start, the fictional book, Hitchhiker's Guide to the Galaxy, right? So in that book, you might have read it, or you might have seen, I don't know if you've seen it or not, but anyways, if you have read it or not, right? Anyways, basically in this book, there was a supercomputer that was developed named Deep Thought, right? And it was programmed to find out the great question of life, the universe, and everything. And that was a number, which was, and it took about 7.5 billion years to come up with that number, and that's all. And does anyone know what that number was? Yeah. So that number was 42. But the point of bringing up this is basically, what if Deep Thought was programmed to run inside the EVM? Would it still have come up with the same number? I don't think so. I think the number in that case, does anyone want to guess what that number would be? You're close, you are closer, but not that close. Anyone else? No worries. So that number is 32 actually. And that is basically, I'll come to that. So basically why 32 is because I think I mentioned initially that EVM executes as a stack machine, and stack is basically a list of 32 byte items, right? So EVM basically, every word, every slot in EVM that EVM reads, it has to be 32 bytes or 256 bits, right? So that's one of the reasons, and again with storage as well, you have 32 byte keys and 32 byte values, right? So every word that, technically in terms of smart contract development, every slot that's used, that's on the basis of, max limit of 32 bytes, right? So that's why the number 32. And I'll be again diving into it a bit more when I come to some, code snippets later. So yeah, this is not it. There's still some stuff, some things to come. So yeah, then this importance of opcodes. Basically, the instructions that I was mentioning earlier, right? They are basically called opcodes, right? And there's a very good website, evm.codes, where you get a list of all the opcodes that are there exist and the gas that they consume, right? And and you also have a playground, play around with those opcodes and how things work with EVM, right? So basically, the smart contract bytecode corresponds to a set of EVM codes. That's the bytecode that gets generated when you compile a smart contract, right? So that is basically a set of EVM codes, right? And each opcode is 1 byte in length, basically, and it can lead to 256 different options, right? But EVM right now only uses around 140 unique opcodes, right? So that's that. Again, I'll be diving into this a bit more when I come to the code snippets, right? Yeah, and this is again a very important aspect of the EVM the account. So accounts are of two types. You might have, again, just refreshing your knowledge or giving you an intro about the same. EOS, basically, your hardware wallets, your MetaMask wallets that you use, which have no code, basically externally owned account, right? This means that there's no code associated with that account. There's no smart contract, right? And then we have the smart contract wallets with your, Genesis safe multi-sig is a pretty good example. Which have an associated smart contract to it. Or so these are two types of accounts, and then these are the properties that each account, both types of accounts have. First is your Ether balance, or a native token balance if you are on any other EVM-based chain. Then we have nonce, which is basically a unique number that gets implemented whenever your transaction gets confirmed. Right, to just keep a track of the unique, the total number of transactions that you've done from that account. So every time you do a transaction, this gets implemented, right? Then we have the interesting bit, which is the code part. So for EOS, as I said, there's no code, so this value is empty, right? But for smart contract, this value is empty. Basically, code is Merkle root tree hash. Of the bytecode that gets of that corresponding bytecode. So, for example, if there's a Genesis safe, so that would be value would be that the hash of that bytecode. I'm not diving into the Merkle Patricia trees that EVM uses because I think that would be too much for this session. But yeah, you guys can read more about it. There are a lot of good resources available. And again, then we come back to storage. Storage again for EOS, as I said, there's no smart contract, so there's no storage involved, right? But for smart contract accounts, since you have Genesis safe, right? It has a smart contract. It has things that it stores in persistent storage. So then again, storage is the hash of the Merkle Patricia trees of that particular storage of the storage structure of the smart contract. Right, but again, not diving deep into the Merkle Patricia trees. We can. I'll have some resources listed at the end, so you guys can have a look and take a look at that. Then so this is a bit more like interesting. Basically, right now, I just wanted to know how many of you people have written a smart contract or are planning to write one. So good amount of numbers. Yeah, so basically, I think what happens is as you grow probably from a technical level in your writing like smart contract code, along with security, I feel this word, right? Gas optimization sort of becomes more and more, important. I feel as a developer, and if you're working, as I said, you have that practice going on, writing code, especially writing smart contract. Right, gas optimizations then become a very, very important part, I feel, into writing very good UX, and which is good for UX as well because you are allowing people to spend less gas and use your feature, for example, right? So these are some very basic, and if you are, when you get a good, good knowledge around EVM, how things work, you can easily, gas optimize your smart contracts. Right. So these are some, I think, some basic techniques that some of you might already know how these things work. But I'm still gonna just let you guys know. And for those who are trying to get into the smart contract development space, basically, so we'll just start with some optimization techniques, how we can save gas, right? And these are some some code snippets from my own code that I have just taken screenshots of. So yeah, first is I think first tip is pretty much that you should use the latest versions of Solidity every time whenever you try to code in smart contracts, because the old versions are pretty much there are deprecated features. And yeah, so it's better that you use only the latest versions whenever you are developing, right? So yeah, so the first one is using custom errors instead of require statements. You might have seen in smart contracts that we have conditions to revert a transaction, right? And we usually do that with a require statement, and there's a message, there's a string message, right? But what you can do with latest versions of Solidity is that you can use custom errors. Basically, this is an example that you define an error, a name, and then you can use revert statements instead of require statements to revert that, right? And you can save gas. I mean, I don't have actual numbers right now, but yeah, I know that this is very cheap to use instead of as compared to the require statements, right? Then we have, yeah, this is another one. So when I was talking about storage and memory, right, there are opcodes that are involved, right, with both of those operations. So with storage, when you load or store stuff, the opcode is called as sload and store, right? And that opcode basically uses 800 gas, right? And there is an opcode, there are opcodes to store data into memory and reading data from the memory, which is mstore and mload, right? And those opcodes cost 3 gas each, right? So you can see that difference, right? So basically what I mean by avoiding multiple reads from storage is that, for example, if you have a smart contract and a function that you are reading stuff, data from the storage, right? For example, if you see there's a variable named reward tokens, right? It's an array, a storage array in the storage, right? And I was reading from this array multiple times in the same method, right? But what I did was I created a memory reference, right? To it, so I can use and read from that memory reference instead of reading from storage again and using 800 gas. So what I did was I assigned a value to the memory and I'm reading from that memory variable instead multiple times, right? And the only thing that you need to know is you should only do this when you are trying to read data. If you try to store data, you always have to store it to the storage variable. Because if you store it to the memory variable, it will not reflect. Because memory, as I said, is only available during the execution time. It's not available after that, right? So just keep in mind that, and you can use this, this syntax to basically, define a reference at the start of your smart contract function, and just read from that reference when you're doing multiple reads, right? So you'll save gas there. The next one is, again, this is sort of very, very basic. You guys might have already seen this on many articles if you have read any articles regarding smart contracts. So this is basically to, pack your structs. In this example, I have a struct named vote, right, with 5 parameters. There's a Boolean parameter, an address, and 3 unsigned integers, right? Now here, can anyone tell me how many storage slots I'm using here? Okay, no worries. So here, sorry, 3. Yeah, no, it's 2 actually. It's not 3. Sorry, it's 2. Yeah, I'll come to that. So basically, why it's 2? Because Boolean only takes 1 byte, right? Address takes 20 bytes, and remember that the storage slot is 32 bytes maximum, right? And the 3 unsigned integers combined use 1 byte, use 32 bytes, right? So both these, because the total comes out to be 53, right? 32 and 21, right? So they cannot fit into 1 slot, right? So that's why they get fit into 2 slots. All these 5 items now get fit into 2 slots, right? What I could have used is a non-cheap way, which was that I could have assigned a slot to each of the unsigned integer, right? So basically I could have just used u into 56. Basically that is 32 bytes for each integer, unsigned integer. But I'm not doing that. I'm trying to save gas by, compressing the amount, the grant ID and the port ID into one slot, right? So that's basically the mechanic around here. If you can, of course, it depends on what data you are storing in. If you can, compress data when you are storing it, so that would be better in terms of structs and in terms of your storage variables as well. And you have to order them that way, right? It has to be ordered that way that, for example, bool and address take one slot and the unsigned integers take one slot. So it has to be ordered that way that it uses, two slots in this case, right? Then again, this is very, very common, but just getting it out there, getting this out there, that of course use constant keywords, because they don't, if you use a constant, it doesn't get, gets added to the storage, but it's just a part of the contract bytecode, so it does not cost you that much gas, right? And again, immutable has again, come with the new Solidity versions. Basically, you define an immutable, any argument as immutable when you are only setting that value inside the constructor of the smart contract. So if, for example, this is a wrap contract reference, right? So I'm only, in this instance, only setting that inside my constructor, right? I'm not setting that anywhere else. So if you're doing that, you can just define them as immutable, and that will save you gas, because immutable variables also are a part of the bytecode, right? And so all the three variables there, not the variables, sorry, all the three immutable variables are part of the bytecode, right? And there are three constants. So yeah, this will help you save gas again. Now then we have the last one, which is again with the new versions of Solidity, you can do this. Basically, there are a lot of smart contract use cases, where we use for loops, right? And what you can do is basically, so basically what you can do is, instead of, if you are working with for loops where the where the loop is bounded by a fixed length, so it's instead of using a traditional for loop like in a traditional manner, you can increment the variable that's the iterating variable in an unchecked block, right? And just define the for loop like you do, but you do the increment inside the unchecked block. Basically, what this means is before Solidity 0.8.2, the compiler version, there were no overflow and underflow checks, right? Basically, what overflow and underflow means that you can only have 256 bits, right? That length is defined. If you go over, or let's say you have defined an unsigned integer, and you are subtracting a smaller value from a subtracting a smaller value from a bigger value, right? So your number that value gets into, goes negative, and then you get an error, right, thrown in the smart contract. And earlier we had libraries like SafeMath, which used to detect these errors, right? But now in Solidity 0.8.0, this variable, the SafeMath behavior, is by default. So you don't need to use any SafeMath libraries or anything, But what you can do, what unchecked helps, is a backward compatibility thing. So you can go back to that way before 0.8.0 behavior, where you had to explicitly check these underflows and overflows. So that's why if you have a fixed length, which means there's no chance of any underflow or overflow happening. So you can define the increment value inside the unchecked block, and you can save gas on that, because if the compiler sees the keyword unchecked, it won't check for underflows and overflows. So for example, it won't check for I being underflown or overflown, right? I'm not sure if that sort of made sense, but yeah, with new versions of Solidity, you can save gas on for loops by defining an unchecked block. Right. I think then I have some a very like some resources which I have found very helpful for myself, and I think people I've seen people using these resources to just broaden their understanding of the EVM. Right, so you can probably take a picture of the slide, or I think the slides will be available later. These are links to these resources, articles, people to follow on Twitter for gas optimization tips, the gigabytes of the space, some videos, some puzzles, EVM puzzles. It's a GitHub repository that you can use just when you get a good basic understanding of how EVM works. And some, I've put in a security challenge, an OpenZeppelin security challenge repository, which is sort of more of a security side of things, but again, EVM knowledge might help with that as well. So, I think that's that. Any questions around this, or any questions around the Web3 space, anything in general? Yeah, happy to answer. I think I started about 2 years back from a hackathon, from hackathons basically. So I participated in a Gitcoin hackathon, and that's what I tell everyone. If you want to get into the space, hackathons/DAOs. I think there are people sitting from developer DAO. I'm also part of it, but yeah, you can start either from DAOs or from hackathons. That's the best place to get knowledge, to get practice that, implement that knowledge somewhere and contribute, to the space and learn as well. I think so. Yeah, my journey started from a hackathon actually, because at that time we didn't have that much of DAOs, and I was pretty much a beginner, right? So yeah.
How do you keep up with all the new stuff that comes out? So let's say something just new came out in Solidity's latest version. So are you a part of any communities, or is it just Twitter?
It's hard to keep up. It's hard. Right away with Web3, everything. There's so much new things, new things happening, and with ZK, EVMs, everything. This is just too much to keep up. But try to get some time out on weekends or something, and try and read some, read articles where I can, and just I think what I do is I just like everything I see interesting on Twitter. So I think then we have a like section on Twitter. We can just see what the posts that you like, and I can see that later. So I think I just do that.
That's a good thing.
Yeah. Either you bookmark or so I just do that. Yeah. Yes.
What are your thoughts around using something like Yule or Inline assembly for?
Oh yeah, I think that's pretty much. I'm also right now trying to get into that space actually.
Yeah, because
I'm not very experienced with assembly and Yule, but yeah, I think I would say as a developer, I think first you should probably get started with one language, either like Solidity or Viper, just to get started yourself once and get that confidence in. And once you have that confidence in, then you can, of course, because all these things, right, assembly and Yule, everything, Huff, all these things are a bit more advanced, right? So, I feel that way, but as I said, I would just suggest that you just get started with one, either it's, Viper or Solidity, right? Just get that confidence in, build some things with that, learn about EVM, gas optimized stuff with that, and then probably dive into, just go it step by step. Yeah, I'm just saying.
Makes sense. Because I see some projects like some contracts of OpenSea, right? They build the whole contract.
Yeah, but they are the gigabytes, right? But I think they also started with Solidity, right? To start off, and then now they are advanced in that stage. That's what I'm trying to say.
Yeah.
That you get to that level in terms of your confidence, how you perceive things, and then probably you can start practicing, assembly like you said, and then dive more into that and use that.
So I was wondering if you had specific suggestions on where to start, because I already have some contracts, which I think I spent quite a lot of time trying to optimize them in the Solidity front, using some of these tricks as well.
Yeah.
I was wondering how to take them to the next level.
Yeah, I think then probably to the next level. I think you have written production ready, like.
Yeah.
Okay, so I think then probably that's a good time if you have experience with these things, like played around with these gas optimization things. Probably it's a good time. I think if you can take time out, just start diving into it. Get started with Yule, simply have. Yeah. I've also, to be honest, I haven't really gotten the time to dive deep into it yet, but yeah.
Thank you.
One question I had was that you talked about your protocol that is on Polygon and Celo, right?
Yes.
So one question that I had in mind is that suppose there is a ERP 721 standard and that is used to mint a lot of entities, and then the other keys came up with ERP 721 which is an optimized version of
Yep.
721, right? So that makes sense when you are minting those contracts on Ethereum because it has a lot of gas. Does it make sense to go for gas optimization and reduce the readability of your code if you are on like LU solutions or?
Yeah, I think good question. I think it has to be a balance, to be honest. I think I don't see it, that way. That of course, as you said, L2s, it's not, I mean, gas is not that much and everything, right? But I think I would still say, I think of course the higher priority I feel with all these hacks, happening around. I think the priority is security. First and uttermost priority is that. But I think gas optimization still, even if you are on L2s, I still feel that you need to give your users the best experience, right? Even if they can save some sort of gas on any of those, in your smart contracts, if you can do any compromisations, any optimizations, sorry, to optimize, I think you should. But I think security always should come first, and then I think probably second to that would be optimizations. Yeah.
I asked that because when we mentioned the OpenSea's seaport contracts came up, then there were discussions around the auditing space that it is difficult to audit this kind of contracts because
then you will need very advanced guys who understand
so
that.
that reduces.
Yeah, I mean again that's a balance, right? I think Uniswap V3. Have you seen the service? Yeah. So they as well for example, they used require statements and they did not use any messages. So people who were I started reading their contracts, and I mean, it was difficult in comparison to V2, the Uniswap V2 version, right? So I mean, it's just a choice, I would say. I think the OpenSea probably, of course, they are the pioneers sort of the space, and they know better. And I don't have any issues with that. I think if they want to go that route, because OpenSea volume is huge, right? And they are on Ethereum, so they have to optimize it anyway, right? And I don't think there's an issue with that, to be honest. I think you can find good auditors. Good auditors can audit any kind of code. I don't feel that this space has too much talent. I don't feel that there's an issue with writing how they wrote the C code contracts. Yeah. Anything else? Anyone else? Okay. Thank you guys for giving me the opportunity to speak.
Informative and fun.
It was great.
Thank you. Thanks a lot.